Welcome to my textbook, Automata and Computability, A Programmer's Perspective. I'm Ganesh Gopalakrishnan, Professor, Calumet School of Computing, University of Utah, Salt Lake City. I written this book in response to a need I felt that the venerable topic of automata and computability must be expressed more from a programmer's perspective, which means I would like to view these theory concepts and formalisms as turning into tools, and also include several ideas in formal verification of systems, model checking, and I have done a reasonable amount of work in that regard. So the book is sold by CRC Press, Taylor and Francis, and I'm fortunate enough to receive 3 comments from Professor David Dill, Emeritus, Stanford, Dr. Ching-Sung Chow, retired silicon engineer from Intel, and Professor Vivek Sarkar, now a dean at Georgia Tech College of Computing. And the book introduces these familiar topics that you have all probably heard and even taught from a modern perspective. So while I do cover the formal languages and their inclusion and containment properties, I also introduce several programmatic constructions. And I'm also lucky to have Professor Jeff Draper of BYU Hawaii draw some cartoons. So here is a person modeling a black portrait. Well, this was Mona Lisa, an intricate pattern of black pixels, and on which somebody put spray paint, which is like Sigma star. So the concept is any language union Sigma star looks like Sigma star. Or if you take away from Sigma star the right patterns, you get one of these languages. Anyway, so that was, and the book itself uses the Jupyter notebooks, or Jupyter, as you probably have heard that mentioned. And this is signified by the book cover having the planet Jupiter with Aurora Borealis. This is an actual image from the credits are inside. And the use of Jupyter allows the subject to be taught on Colab in an incremental interactive fashion. And like I said, there's a Google book page on it. So let us concentrate on what this video series is going to be. This video series is an attempt on my part to introduce the material without purchasing my book. If you purchase my book, you will get the added benefit of reading the chapters, but you simply don't need to. You can use any other textbook and use the software and supplement your current material with this book. So the book actually covers several chapters that may be familiar and several chapters that are not familiar in this context. So you do have the notion of languages, all introduced using Python, and deterministic automata, non-deterministic automata, regular expressions, conversions. All these will be illustrated through interactive and even animated sequences. Then there is a chapter on derivative-based parsing, which is a gem that is lost in the annals of computing, where the late Professor John Brzozowski introduces the idea of computing the derivatives of regular expressions, which is a very nifty way to use regular expressions themselves as state descriptors. And I have written a complete pattern matcher that handles negation. And this is something that students may enjoy. So in one page of code, I'm showing how the derivative processing is done. And also there is another page of code somewhere, maybe before, which introduces the parser for regular expressions. And together, this, here's the parser for regular expressions in a page. So together, these two illustrate derivatives. So like that, I have several other topics, such as binary decision diagrams, which is the workhorse of model checking, at least the old style model checking tools. And binary decision diagrams are introduced as compact Boolean functions, also as minimal deterministic automata. Again, a Jeff Draper cartoon says that if you have 2 to the 2 to the n Boolean functions, like Dr. Knuth devotes in his volume 4, 140 pages on PDDs, calling it one of the more interesting data structures in the last few decades. PDDs are very versatile, and I do show minimal automaton construction mirroring BDDs, and BDDs are nothing but a little bit more optimization applied to minimal DFA. And that is one extra that you get. And these are all chapters whose recordings will be presented. And in addition, I do have material on lambda calculus, so you can see. And I do have material on post correspondence, where again, when you teach computability, you would like to introduce post correspondence problem as one of the starting points for reduction. And there again, I do have an interactive tool that I ported from one of the amazing master's theses done at the University of Edmonton. And that code was the fastest PCP solver that I found. Okay, so now I'm going to show you, give you a tour of these book chapters to entice you to watch the whole series. So first of all, I'm going to go to the overview of 3100. You just need to approach my public GitHub and load the GitHub. And if you see an open in Colab, you can click that. Otherwise, have a Colab extension planted in your browser. That'll take you to Colab. And there are some YouTube videos that I sometimes embed that you can watch. Otherwise, you just execute an import command, which brings in the material that powers these tools. And at that point, you can actually start interacting with the tools that I have built. And just to give you a quick taste, there is a Jove editor that was a piece of software that one of my teaching assistants, Paul Carlson, wrote. I wrote most of the other tools and codes, and Paul Carlson wrote wonderful animation software. So to quickly see what Jove can do, you can click on the DFA panel or the NFA panel or the PDA panel or Turing machine panel. If you click on the DFA panel, it gives you a markdown language in which I describe deterministic automata with comments. And you can actually click on animate, in which case it renders the DFA in question as a diagram. And the students actually learn the compiler that takes my markdown and compiles it into this diagram, and also compiles regular expressions to NFA and things like that. So now you have watched Turing machine deterministic automaton. You can similarly watch push-down automaton animate. There's a starter code. So without any installation, just with a few clicks, you can actually start animating machines. So it actually checks for syntax, and let us see whether it receives the animate. Yes, a response to the animate. And in this case, you can see how the push-down automaton works through animation. So this is a quick preview of one of the facilities. You can write individual machine descriptions in a markdown, and it's highly encouraged that the students write comments because each state carries a certain amount of semantics, the meaning. So it's good to document it, much like you document a low-level assembly code. And there are many utilities, so you can actually import the right descriptions and check for acceptance. There's a way to generate all possible test strings according to a length criterion, like nth numeric. And this enumerates strings in numeric order, which is a lexicographic order wise, listing per length group. Test strings is being mapped over, and you are testing. So this is the set of test strings which exhausts all the lower lengths before it goes into the higher length. And each length group is listed lexicographically. So if you run the acceptance test, you can actually, in one sense, see it. There is functional programming heavily emphasized in the usage of the tool and more in the implementation. So if you want to expose the code underlying these machines, you have plenty of opportunities. You can animate individual machines by importing its own animation widget and run it. And then you can actually see it. But animation is only initial sugar coating. There are many interactive commands through which you can compose commands and study the machines. So this is how this notebook is organized. And now let me show you what else exists. So if you want to teach, let's say, binary decision diagrams, you come to the PBL module, and you can actually use the binary decision diagrams as a very effective way to introduce the concept of conjunctive and disjunctive normal forms, all extracted from binary decision diagrams. And you can run these cells and ask the students to do a set to 3-set to click reduction and try to remove clauses and see the satisfiability in the Boolean calculator. So I start with a simple markdown language. This tool's engine is written by Professor Tyler Sorensen of University of California, Santa Cruz, when he was my student, and I packaged it into Colab. So you can actually test puzzles from Lewis and Carroll's book, or basically his writings. And you would see that a certain proof by contradiction did not go through because you forgot one corner case, which is leading to a 1. And that corner case can be eliminated, like I show, by turning on the frame axiom and change this to the right frame axiom. And if I do that, and if I do, in this case, old cannot be at the same time if and only if not young, I think. Let us try that. So that is the frame condition that the system did not keep in mind when doing the proof by contradiction, and then you get a contradiction. So this is a good way to introduce Boolean satisfiability, map coloring. So you can actually get a map color of all the adjacent states in a certain part of USA. And this BDD is all the legal colorings. So moving along, you can also see other modules. So I have taught this course many years. So older years has the material for older years. In 2024, I offered this course, and that is kept here. There are many tools that show calculators and ambiguity in parsing. So these are all introduced later on when you watch the video series. And let us look at derivative parsing. So that is what I briefly showed. You will get to that. Let us look at post correspondence. So there's a post correspondence widget that solves simple post correspondence systems. And if you run these, you will see the post correspondence problem for a set of tiles being solved. And this is a good motivation for introducing how the acceptance problem of Turing machines can be mapped to post correspondence in a tile sense. And here's the solution for a very small post correspondence tile system, which only has 3 tiles and whose minimal solution length is pretty long. So that is something that you can do. And you can also go and play with the lambda calculus. The Y Combinator is introduced. The eager version of Y Combinator, the eager version is introduced. And chapter 17 is where I teach how church numerals are encoded and how you can build several functional operations. And if you run out of steam and have too many sessions, you can retire some sessions, then come back and then run Colab. So this is all free, and students don't need to install any software. I have taught this class several times using Colab, and hundreds of students work on this software without any hiccups in terms of the resources. So I do show, this is the chapter 17, which I ran into, which is the binary decision diagrams chapter. Let us go to the lambda calculus chapter, so Turing Church, I think. And Turing Church chapter shows you how church numerals are encoded. And from church numerals, you can build up to addition, zero test, successor, predecessor, then the Y Combinator. All these are illustrated in mathematical form in the textbook, but also executable, all in Python. So this chapter culminates with calculation of factorial using Y Combinator. So in this manner, the students can experience the entire material that is typically taught in courses like this. But many courses don't introduce lambda calculus. It's a very easy one lecture that you can slip in, which I did in my course sequence. So I hope this quick tour through the facilities of the tool gave you a good idea of what the tool software contains. And if anyone is tempted to read the software, it is all a collection of simple Python files, which are extremely readable. And the entire setup is here. So let us say if you want to define DFA, you can actually see the old Colab notebook that I had run this and debugged, put in as a collection of definitions. This includes DFA, union intersection minimization, and all the other operations, and plenty of material, interactive material awaits you. So I would encourage you to jump in and start trying the tools and have fun with it. So let us invite you to start watching the series. Thank you again, and hope to see your comments. You can email me. You can easily find me on the web at ganeshutah@gmail.com or ganesh@cs.utah.edu. So whichever you like, you can type an email. I highly appreciate hearing from you. And I will include a link in the next set of videos when you come to trying out various items of software and all that. So my homepage is www.csutah.edu/ganesh and ganesh@cs.utah.edu. You can find me here. So thanks again and see you next time, and watch this series and enjoy. Thank you. Bye.